Oumuamua has now left our solar system, passing beyond Neptune's orbit and venturing so far that it can no longer be studied by any telescope. Its origins and nature remain mysterious, continuing to fuel heated debates in the scientific community. Could it be a fragment from a shattered planet flung towards us by a distant star? Or perhaps it's a piece of alien technology, either intentionally or accidentally sent here by some unknown intelligence. Surprisingly, or perhaps unsurprisingly, both theories are still proposed as plausible. The object's strange characteristics make it hard to classify as a comet, asteroid, or something artificial. Nevertheless, such a classification might be critical, especially since 6 new objects exhibiting similar baffling behavior have been discovered in our solar system. Objects that, like Oumuamua, accelerate without a clear explanation of the force behind it. Today we'll explore Oumuamua and these 6 newly discovered dark comets, diving into the theories that have emerged as scientists continue to grapple with an object that remains largely unexplained. For a quick recap, Oumuamua was the first recognized interstellar object to enter our solar system. It did so on October 19, 2017, and was first spotted by the Haleakala Observatory in Hawaii. Scientists immediately noticed something odd about it. The object was small, measuring perhaps between 100 and 1,000 meters in length, and its shape was thought to be either cigar-like or disc-shaped. Its trajectory and speed indicated that it would eventually leave our solar system, so scientists concluded that it couldn't have originated here. This led them to give it the Hawaiian name Oumuamua, meaning scout, or first distant messenger, as the first of its kind that we've detected, although not necessarily the first interstellar object to pass through our solar system, given the trillions of potential candidates that might have done so unnoticed. Scientists were eager to study Oumuamua to learn about its properties and how they compared to objects in our own solar system. As they observed it, they began to detect some peculiarities. Initially classified as a comet, it became clear that Oumuamua lacked the typical features of a comet, such as a coma or tail, making it more similar to an asteroid. But this absence raised new questions when Oumuamua was observed accelerating as it moved away from the sun, a phenomenon that defied standard physics. The acceleration was minor, about 17 meters per second at its closest approach to the sun, but still enough to spark significant interest. It was clear that Oumuamua wasn't behaving as predicted. Scientists hypothesized that something must have been pushing it. A few initial theories were quickly dismissed. The acceleration wasn't due to solar winds, which are known to push small particles in space, but are far too weak to explain such a noticeable acceleration in an object the size of Oumuamua. The best photos of Oumuamua only showed a tiny speck, making it hard to determine its exact shape. But variations in its light curve suggested that it was an irregularly shaped object, possibly tumbling through space like a disk or cigar. Scientists compared Oumuamua to comets, which accelerate as they approach the sun. As a comet's ice warms, it sublimates into gas, which forms the characteristic tail and also provides a thrust, pushing the comet away. However, no outgassing was detected from Oumuamua, which led to more exotic theories. One such theory came from Harvard professor Avi Loeb, who in 2018 proposed that Oumuamua could be alien technology. He suggested that solar winds could cause the observed acceleration if Oumuamua were incredibly thin, between 0.3 and 0.9 millimeters thick. Loeb argued that such an object was unlikely to form naturally and suggested it could be a light sail, designed to harness solar winds and travel between stars. This theory was met with resistance from other scientists. Daryl Seligman, a postdoctoral researcher at Cornell University, countered Loeb's ideas in a 2020 paper, proposing that Oumuamua might be emitting an invisible gas such as hydrogen. This would explain the lack of detectable outgassing, as hydrogen is difficult to detect with telescopes. Seligman suggested that Oumuamua might be composed largely of hydrogen ice, which sublimates as it warms from solar radiation, providing the observed acceleration. Loeb dismissed this theory, pointing out that the starlight in interstellar space would not be strong enough to melt such hydrogen ice before it reached our solar system. Loeb remained convinced that the object was artificial. In 2023, Seligman and University of California assistant professor Jennifer Bergner advanced a new theory, proposing that Oumuamua could be a dark comet. They suggested that Oumuamua's structure might trap hydrogen gas, which is released when the object warms up. This could explain the acceleration without visible outgassing. Loeb continued to reject this theory, arguing that Seligman's math was flawed, and maintaining his stance that Oumuamua was likely an alien spacecraft. Seligman, however, began to consider the possibility that other dark comets might exist. He and his colleagues examined data on other objects in our solar system, and they discovered 6 small objects that exhibited similar unexplained acceleration. These objects were all near Earth, making them prime candidates for future missions. One of these objects, 1999 KY-26, is scheduled to be visited by the Japanese Hayabusa 2 probe in 2031. This mission, which was initially focused on asteroid sampling, has been extended to include a flyby of 1999 KY-26. This tiny object rotates rapidly and may offer further insights into the source of its strange acceleration. While it remains unclear which theory is correct regarding Amura, the discovery of other accelerating objects is an intriguing development. Though Amura is now beyond our reach, these new objects may hold the key to understanding its origins and the mechanisms behind its acceleration. If they too are dark comets, it could offer a breakthrough in our understanding of these mysterious objects. Seligman may be proven correct, but if a small hatch opens and an alien figure waves at us before zipping off beyond the solar system, we might regret not giving Loeb's theory more attention. I believe the former is more likely than the latter, as there's no way 1998 KY-26 is a light sail. We have clear imaging of it. Either way, it will be fascinating to study. Ultimately though, it may turn out that neither theory is entirely accurate. That's the wonder of science. The more we explore the universe, the more unexpected phenomena we encounter, and the better our theories become. Perhaps one day we will find more objects like a Muamoa from beyond our solar system, which could provide more clues about its nature and origins. The search for dark objects that might act under invisible forces always sparks my curiosity. By 2031, we may have answers, or we may simply face more questions. Only time will tell. The search for alien life has led scientists to send robotic rovers to other planets, astronomers to scan the skies with radio telescopes, and satellites to carry data back to Earth. Many have spent countless hours looking for any sign that we are not alone. We do this because, in the vast expanse of the universe, it's hard to accept that we might be the only ones to have developed life. The discovery that we aren't alone would be humanity's most profound revelation. Some believe that while we've been searching for extraterrestrial life, aliens have already been trying to find us. They claim that aliens are here, hiding in plain sight. Unfortunately, much of the evidence is dubious. Fake videos, blurry footage, or misidentified natural phenomena or satellites, which has made many skeptical of such theories. Some believe the US government has even spread UFO conspiracy stories to distract from secret military projects like the stealth bomber. Ascribing extraterrestrial origins to these occurrences is often unscientific and factually incorrect. Just because we don't understand something doesn't mean it's alien. However, in 2022, NASA, the US Navy, and other US government agencies began investigating the growing number of UFO sightings, and the results were unexpected. They found so much compelling scientific evidence, solid data from advanced detection equipment, and credible reports from military pilots, that it became rational to investigate further, no matter how strange it seemed. It's no longer reasonable to dismiss the possibility that something unusual is happening, and the only question now is, what is it? In 1947, businessman Kenneth Arnold made the first modern UFO sighting. He claimed to see 9 crescent-shaped objects near Mount Rainier, moving at incredibly fast speeds. Initially thinking they were secret military jets, Arnold and other witnesses later wondered if they might be extraterrestrial. This led to the term flying saucers entering the public consciousness. The media picked up the story, and more reports of UFO sightings followed. However, the US military didn't take these sightings as seriously. After World War II, the military set up programs to investigate UFOs. But by 1969, the last of these programs, Project Blue Book, concluded that most of the sightings were simply misidentifications of natural phenomena or human-made aircraft. With this damning report, funding for UFO investigation stopped, and UFO sightings became stigmatized. Those who reported seeing UFOs were often ridiculed. But the question remained, if aliens exist and are visiting Earth, where's the proof? Reliable proof would need to come from multiple trustworthy witnesses and be backed up by recorded data from different sources. It would also need to exhibit characteristics that rule out any natural or man-made explanations, and the more repeatable the sightings are, the more opportunities there are to study them. This brings us to 2004, when a US Navy aircraft carrier, the USS Nimitz, had an encounter with a mysterious object near the Southern Carolina coast. The USS Princeton, another nearby vessel, had recently upgraded its radar and detected strange objects descending from 80,000 feet to 20,000 feet at an incredible speed. Days later, 2 FA-18F Super Hornet jets were sent to investigate. They quickly spotted a tic-tac-shaped object moving erratically above the ocean, with no visible means of propulsion. The object then shot away at a speed the pilots had never seen before, later reappearing 60 kilometers away in under a minute. This was witnessed by 4 trained pilots, recorded on aircraft cameras, and tracked by advanced ship-based radar, providing reliable evidence. The incident was logged, but no immediate action was taken. However, in the years since, similar reports have kept coming in from Navy and Air Force pilots. Between 2004 and 2021, 144 UFO reports were filed, many witnessed by multiple personnel and often involving near-miss incidents with jets. By 2022, reports had jumped to 510. These objects exhibited various behaviors. Some looked like drones but stayed aloft far longer than current technology allows. Others traveled in formations with unprecedented acceleration. Some seemed capable of flying and submerging underwater, and some appeared to defy wind currents, staying still or even moving against the wind. While some reports could be glitches in technology, there's still the issue of the Navy not knowing what these objects are. To avoid the stigma associated with UFOs, the US Navy now uses the term UAPs, unidentified aerial phenomena, and is actively investigating them, collaborating with outside experts like those at NASA. Despite ongoing investigations, the US government still doesn't have a clear answer on whether these objects belong to other nations or are something else entirely. NASA Chief Bill Nelson has acknowledged the mystery, stating that while they hope these phenomena aren't related to adversarial technologies, they can't rule out any possibility. As the search for answers continues, questions about the origins and nature of these objects remain unanswered. Perhaps they are the product of human technology, or maybe they represent something far more extraordinary. What do you think? Could these phenomena have simple explanations? Or do you believe they are signs of extraterrestrial life? Let me know in the comments. If you're interested, I can explore this topic more in depth, especially when the next US government report is released later this year. In the Milky Way alone, there are estimated to be 100 billion planets, with 30 million located in the Goldilocks zone, just the right distance from their stars to support life. If only 1% of these planets develop civilizations capable of exploring space, we should expect signs of thousands, if not millions, of alien races across our galaxy. As Nobel Prize-winning physicist Enrico Fermi famously asked, "Where is everyone?" Today, we'll delve into some potential answers to this question. While we can't say for sure if aliens exist, there are surprising obstacles that might prevent us from detecting them, even if they do exist. Let's start by considering the obvious possibility: maybe there's no one out there. In our previous video, we've explored the odds of alien life and concluded that it's incredibly difficult for life to form from non-living materials. Even if life does emerge, it's unlikely it will evolve into intelligent beings like us. This means it's entirely possible that there are no aliens and the universe is empty. If that's the case, Earth might be the only planet with life, and we'd be the first to reach this level of development. All other planets might be barren. In this scenario, we'd be free to explore the universe, encountering only the life forms we've brought with us from Earth. While this theory is reasonable, there's no definitive evidence to prove it. However, this is not the only explanation for why we don't see alien signals. There's also the matter of natural limitations. To establish contact with an alien civilization, 2 things must happen. Either we send out a message and they respond, or they make the first move by contacting us. This could be through spaceships or unmanned probes, but there are major challenges with methods beyond sending messages. For instance, sending a spaceship is incredibly complex. With current technology, it could take millions of years for an astronaut to reach a distant destination. Voyager 2 took 49 years to leave our heliosphere, and the nearest star is 4 light years away. To get there, it would take 81,000 years, or 2,700 human generations, assuming aliens live close to us. Even with future technological advancements, achieving light-speed travel is virtually impossible, requiring more energy than the entire universe contains. Therefore, unless we or aliens discover a breakthrough, sending radio signals is the most feasible way to communicate. Though it's not impossible that one day we could break the speed limit, scientists have proposed exciting ideas like manipulating space itself, instead of moving at light speed. For now, however, it's much simpler and cheaper to send light or radio waves, so let's assume that first contact with aliens will happen through signals. However, there's still a limitation. Radio and light signals travel at a fixed speed, the speed of light, about 300 million meters per second. This sets a limit on how far we can detect alien signals. If they decided to respond immediately to our signal, their reply would still take time to reach us. For context, we only started using radio in the late 19th century. Therefore, we can only communicate with civilizations within 60 light years of us, because a signal sent in 1900 would take 60 years to reach them, and another 60 years to return. Our galaxy is about 100,000 light years across, so our communication bubble is incredibly small. On the other hand, if aliens initiated contact, we could potentially detect signals from a civilization billions of years old, provided it was within the reachable distance. This leads to a question: why aren't we seeing any alien signals? Well, we have actually detected some signals. We just don't know what they are. A famous example is the WOW signal, detected in 1977 by the Big Ear radio telescope. It was an intense 72-second radio burst that stood out from cosmic background noise, prompting the researcher to write "wow" on the printout. It was highly consistent, unlike the erratic signals typically seen from natural sources. However, by the time Big Ear was able to look again, the signal had disappeared, and we've never detected it again. So, was it a glitch in the equipment, a comet passing by, or an alien attempt at communication? We can't say for sure. The problem is, the Big Ear telescope could only rotate within the Earth's motion, so it couldn't stay focused on one spot for long. As a result, we don't know if more signals came from that area afterward. The researchers couldn't wait for extended periods to track a potential alien signal, as funding and time were limited. SETI, Search for Extraterrestrial Intelligence, faces a similar dilemma. Resources are finite, so telescopes are generally used to scan broad areas of space, hoping for a lucky hit. This method is more efficient, but it means we may be missing out on critical signals. There have been many signals like the WOW, signal that we don't understand, but without follow-up research, it's impossible to confirm their origins. This highlights one of the challenges of the search for extraterrestrial life. We might be missing evidence because we're not dedicating enough time to closely monitor specific regions of space. In conclusion, we might not be detecting aliens simply due to the limitations in our search methods. While there are many theories about why we haven't found them, the technical challenges play a significant role in this puzzle. If you're intrigued by these ideas, I'll explore other speculative theories in another video. Do you believe aliens exist? If so, why do you think they haven't contacted us? Feel free to share your thoughts in the comments. The search for alien life is complex, and we're only scratching the surface of this fascinating topic. We've spent a considerable amount of time on this channel discussing various reasons why we haven't heard from aliens. However, on the flip side, what are the strongest pieces of evidence suggesting that they may have already tried to contact us? Which signals stand out as the most likely candidates for messages from extraterrestrial civilizations? Instead of focusing on why we haven't heard from aliens today, let's explore the possibility that we already have. When it comes to signals from alien civilizations, there's quite a bit of uncertainty about what exactly we should be looking for. After all, aliens are by definition completely foreign to us. It's difficult to predict what we should expect from them, since they may have evolved under conditions completely different from our own, and could have cultural frameworks that are perfectly logical to them, but completely perplexing to us. Their way of saying hello to the universe could be very different from ours. Researchers exploring signals from other worlds must remain very open-minded, as extraterrestrial communication might take forms we can't even imagine. However, this flexibility makes it possible for such signals to be misidentified as coming from natural sources we don't yet fully understand. So how can we distinguish them? Let's take a closer look at a few examples. In 2019, as part of the Breakthrough Listen initiative, the Parkes Radio Telescope in Australia was studying Proxima Centauri, the closest star to our solar system, to learn more about stellar flares. However, when the data was later reviewed by SETI, Search for Extraterrestrial Intelligence researchers, something unexpected was found, a signal that would later be known as BLC-1. Could the star closest to our own be home to advanced alien life? The signal was intriguing because it couldn't be easily dismissed as coming from a known natural source. It lasted for several hours, which was longer than the usual time it takes for a human satellite to pass overhead. It also exhibited frequency shifts, implying some kind of movement relative to the telescope, suggesting it wasn't from a stationary source causing interference on Earth. One of the most compelling aspects of the signal was its narrowband nature. In nature, radio waves rarely have such a tight frequency range. They typically fluctuate. The only sources that produce such a precise signal are technologies, either human or alien. However, despite the intriguing characteristics of BLC-1, there were still unanswered questions. While it didn't match any known sources of interference from Earth-based technology, further analysis revealed that similar signals had been detected on other occasions, regardless of where the telescope was pointed. These signals were inconsistent with BLC-1, and when further observations were made, the original signal was not detected again. Although no clear explanation for its origin was found, it's still possible that BLC-1 was an instance of interference rather than an alien transmission. Next, let's look at another candidate, SHGB 02+14a. When SETI's Project Ozma began in 1960, Frank Drake theorized that if extraterrestrial civilizations were trying to communicate with the universe, they would likely use the frequency of 1,420 megahertz, the natural emission frequency of hydrogen, one of the most common elements in the universe. The idea was that aliens might use this frequency as a common ground for communication. This theory led to SHGB 02 plus 14A becoming a signal of interest, because it was detected at exactly 1,420 megahertz. SHGB was detected 3 times in 2003 using the Arbo telescope and the computational power of 5.2 million home computers as part of SETI's ATOME initiative. The signal didn't appear to be interference, but it was also too weak to confirm whether it was definitely technological. What made it especially strange was its location. It originated from an area devoid of stars around 1,000 light years away from Earth. Furthermore, the signal exhibited drift in its frequency, suggesting it might have been emitted from a planet. However, for it to match the behavior expected from a planet, it would need to rotate at an incredibly fast rate, 40 times faster than Earth, which seemed highly unlikely. Also, each time the signal was detected, it began at exactly 420 megahertz, which makes it incredibly unlikely that we would observe an orbiting transmitter starting at the same frequency each time. By examining how signals like BLC1 and SHGB are evaluated, we gain an interesting insight into SETI's methodology. It aligns well with this famous quote from Sherlock Holmes, as penned by Arthur Conan Doyle. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. Each time researchers come across a potential signal, they begin by ruling out all possible alternatives. Could it be interference from a satellite? Is there any known natural source that might explain the signal? If no logical explanations are found, it opens the possibility that the signal could be of alien origin. Unfortunately, even when human interference is ruled out, there's still the possibility that these mysterious signals might be the result of natural phenomena we haven't yet discovered. This brings us to the discussion around fast radio bursts, FRBS. These powerful millisecond-long bursts of radio waves could, in theory, be a byproduct of alien technology. Hundreds of FRBs have been detected across the sky, and although most occur outside our galaxy, one was detected within the Milky Way in 2020. Scientists are still unclear about their origin, but some theories suggest they could come from neutron stars, black holes, or even alien technology. The CHIME telescope in Canada is particularly good at detecting these fleeting bursts because it doesn't focus on one point in the sky. Instead, its design allows it to capture data from an entire section of the sky at once. It has detected both repeating FRBs and one associated with a magnet or star. Perhaps FRBs are linked to such stars, or perhaps not. Regardless, the mystery remains, and the search for their origin continues. If we could identify the true cause of FRBs, we would have a clearer understanding of their natural origins. Or, just perhaps, we might finally discover evidence of extraterrestrial technology. For now, we don't have a definitive signal from an alien civilization, but that doesn't mean we won't find one in the future. The search is ongoing, and it's always possible that the next signal we detect will be the one that we can't explain, defying all alternative explanations. Until then, we continue to search, hopeful that one day we might receive that signal that confirms we are not alone in the universe. In 1753, an event occurred that added another layer of intrigue to the phenomenon of ball lightning. Gore Rickman, a well-known electrical researcher, was attending a conference in St. Petersburg when he noticed a storm approaching. He quickly set up a kite experiment similar to the one Benjamin Franklin had conducted the year before. According to a witness, as Rickman was carrying out the experiment, a fiery blue orb descended the string and struck him, knocking the engraver unconscious. An autopsy later revealed a red mark on Rickman's forehead, consistent with electrocution injuries. A particularly fascinating account of ball lightning comes from 1963, when R.C. Jennison, a researcher at the University of Kent, was flying from New York to Washington. Late at night, the plane was enveloped in a bright electrical discharge. Moments later, a glowing sphere about 20 centimeters in diameter emerged from the pilot's cabin and traveled the length of the aircraft. Jennison published his detailed observations in Nature magazine in 1969. These credible accounts prompted scientists to consider various theories about the phenomenon. One theory suggests that ball lightning could be a hallucination induced by the magnetic fields around lightning strikes, citing similarities to hallucinations during epileptic seizures. However, this doesn't explain the physical damage often associated with ball lightning, such as Rickman's injuries. Another theory proposes that ball lightning might be a form of contained plasma reaction, similar to St. Elmo's fire, which occurs when the voltage between the air and ground is sufficient to break air molecules into highly excited particles. This theory suggests that the plasma in ball lightning forms a self-contained bubble that behaves like a soliton, a self-reinforcing wave that maintains its shape as it moves. In 2000, John Abrahamson and James Dennis from the University of Canterbury proposed a theory where a powerful positive lightning strike could vaporize soil molecules, releasing energized nanoparticles that then react with oxygen in the air, producing light and heat. This theory gained support in 2012 when researchers in Lanzhou, China, recorded an orb-like phenomenon after a lightning strike. The spectrometer readings showed emissions from silicon, calcium, and iron, elements commonly found in soil, lending support to this model. However, the vaporized silicon hypothesis doesn't account for certain behaviors of ball lightning, such as passing through solid objects. This discrepancy suggests that ball lightning might be a collection of different phenomena, not just one single event. Scientists have also tried to recreate ball lightning in laboratory settings. In 2006, researchers at the Max Planck Institute produced a ball lightning-like effect when discharging a high-voltage capacitor into water. Similarly, in 2018, experiments at Tel Aviv University created a plasma ball resembling ball lightning by using a microwave beam on silicon. These laboratory-created phenomena could be similar to natural ball lightning, but the question remains whether they are identical. In another breakthrough, researchers in 2018 created a synthetic magnetic field that models the electromagnetic field believed to exist in ball lightning. This discovery may help explain some of the characteristics of ball lightning, such as its ability to pass through solid matter, but further research is needed to confirm these findings. Switching gears, let's explore the search for Planet 9, a hypothetical planet that some scientists believe exists in the outermost reaches of our solar system. Many years ago, astronomers used the knowledge of planets' movements in the sky to map out our solar system. But the farther planets were from Earth, the harder it became to detect them. Uranus, the next planet to be discovered after Saturn, was identified using a telescope in 1600s, England. It wasn't until 1781 that Sir William Herschel officially discovered it by accident. The discovery of Neptune, the last known planet in the solar system, came about thanks to mathematics, rather than observation. In the 1840s, French mathematician Urbain Le Verrier calculated that Uranus's orbit was being affected by the gravity of another planet. This led astronomer Johann Galle to find Neptune in 1846, exactly where Le Verrier had predicted. In 1903, Percival Lowell published a book proposing that there must be a planet beyond Neptune, which he called Planet X. He believed that this unseen planet was affecting the orbits of Uranus and other celestial bodies. Although his search led to the discovery of Pluto in 1930, Pluto was too small to be Planet X. Lowell's work inspired many others to continue searching for Planet X, which some now believe could be the mysterious Planet 9, an object 5 times the size of Earth, lurking far beyond Neptune. Scientists are still debating whether Planet 9 exists, or if it's just an unproven theory, but the search continues with great interest. Even after a century, Planet X, or Planet 9, has yet to be officially discovered. So why do we still believe it might exist? Much like when Neptune was discovered, not all objects in the solar system are following their expected orbits. In 2016, astronomers Mike Brown and Konstantin Batygin, studying objects in the Kuiper Belt, noticed something unusual. The Kuiper Belt is a region beyond Neptune, spanning from 30 to 55 astronomical units, AU, from the Sun. Brown and Batygin observed that 14 Kuiper Belt objects were clumping together in an unexpected pattern in their orbits. They argued this was evidence of an unseen force, possibly a planet, drawing them into these unusual orbits. Brown and Batygin maintain this theory and continue to search for the planet they believe is there, asserting with 99.6% certainty that Planet X exists. According to them, Planet X would be large, with a mass at least 5 times that of Earth, and most likely orbit at a distance between 35 to 50 astronomical units from the Sun. For context, Neptune orbits at 30 astronomical units, so Planet X would be much farther out. If it exists, it could take around 10,000 years to complete one orbit. The Sun would appear as dim as the Moon from Planet X, making it an extremely cold and dark place. There's also debate about how Planet X could have formed, whether it was created within our solar system, captured by the Sun's gravity from a passing star, or if it's a rogue planet drifting through space. However, not all astronomers are convinced of Planet X's existence. In 2020, 2 major surveys, the Outer Solar System Origin Survey and the Dark Energy Survey, examined over 1,000 Kuiper Belt objects but didn't detect any unusual clumping or perturbations in their orbits. Some believe that the clustering observed by Brown and Batygin could be due to observation bias, as these objects are hard to spot. Alternatively, the clumping might be due to gravitational occultation, possibly caused by Neptune's movement early in the solar system's history. The biggest question remains, if Planet X is out there, why haven't we seen it? Modern telescopes and computers make it easy to scan the regions where Planet X is believed to be, and astronomers have already surveyed large portions of these areas without finding anything. Even Brown and Badigian have reviewed more than half of the predicted locations without spotting Planet X. In fact, I participated in a citizen science project on Zooniverse to search for Planet 9, and while the project uncovered nearby brown dwarfs and stars, Planet 9 is still elusive. Despite this, it doesn't entirely rule out the possibility of Planet X. One explanation for its continued evasion could be its lengthy orbital period. If Planet X is currently at a specific point in its orbit, it could be hidden behind a cluster of stars or at the farthest point from the Sun, where it's too dim to detect with all but the largest telescopes. There's also a chance that a photo of Planet 9 already exists, but has been misidentified as a star, especially given the vast number of stars that need to be tracked. With Planet X's 10,000-year orbit, it could easily take years before anyone realizes that a star is slightly out of place compared to previous photos. The search continues in two primary ways. Those looking for Planet X are using powerful telescopes like Subaru, which could potentially spot the planet within the next 5 years. Meanwhile, Brown and Badigian continue combing through existing data, hoping to identify the faint, misplaced dot that could be Planet X. It's a long and tedious process, but it's fascinating. Historically, amateur astronomers played crucial roles in discovering planets. Uranus and Neptune were both found by stargazers using telescopes. So while Planet 9 might be incredibly distant or non-existent, it's possible that someone like you or me, through a citizen science project or amateur stargazing, might be the one to find it. Thanks for watching, and I'll see you next time.